Are we live? Yes, right? Let's see two edits, 363. And yeah, I'm live. Let me open the chat here. Finally, there's no thumbnail on my screen. Yeah, okay. Uh, the video is properly, but that's fine. Okay, let me register the today's concept and we're good to go. VS Code is also ready, right? I keep it myself at center. If it looks disturbing, then I can shift. Just let me know. So like I have enabled the voice cancellation. If it is properly, that's fine. Okay. And quite better. That's Takashi is a member of Astronomy Club and, and is organizing his nighttime sky observation record. The observation data is recorded as a grid image. Height. Okay, we are given a grid. One is the top cell. Okay, so it's a one base indexing. The ith observation data given by the string SI. Okay. T means star is captured in the cell and dot means nothing is captured there. Given the observation, find the position of all the cells that contain star. Output the star in ascending order of row number. It's same row number and ascending order of column. This is row, this is column. Right? So what are the inputs? H and W. H and W are the inputs. And let me take the string input. Say A of H. H I plus plus string S and C is S. Right? And we'll iterate this string if S of J is equal to T, that means there is a star, right? And we create a vector of pair answer. Then we'll push answer dot push back I comma j and simply sort our answer and we'll print the answer. Actually I plus one, j plus one. It's a one base index, right? What we'll do is we'll print answer. Auto I comma j from answer. Out I and j. That is what they asked, right? Oh, we also print the size of how many stars we have captured. Answer. Yeah, very fast. We are good to go to next. We are good to go for next question. That is passing, right? 52. Yeah, we got AC. Let's move to the second question now. Takashi works in a general affairs department of a company. He needs to organize a meeting that all and member and employees must attend. Okay. The company is M meeting room. Okay. Each employee, due to scheduling constraints, there is a positive integer PI representing the participation condition. Employee can only attend in a meeting room whose number is a multiple of PI. In other words, employee can attend meeting room J if J is a multiple of Pi. Wow. Takashi wants to find a meeting room that all employees can attend. Find one meeting room, right? Or Takashi wants to find a meeting room. Okay, we have to find one room that all employees can attend. Specifically determine whether there exists a meeting room J such that J is a multiple of Pi for all the i's. If such a meeting room exists, print yes, otherwise no. So we need to find uh, uh, what we can do is we'll do a GCD. If GCD is less than equal to M, that means we get a meeting room, right? J is a multiple of P. Okay, okay. So J is a multiple of P. So it should be LCM. Yeah. If LCM is less than equal to M, then we have to print yes, otherwise it's no. Actually, J should something like this. Let's say X into P1 into P2 into Pn. Then only J is a multiple of this all P, right? X is anything. In and C and M, we have a LCM. PCB, I have a template, right? PCB underscore LCM. Okay. And what we can do now is for and in answer is equal to 1 for int I is equal to 0, I is less than n, I plus plus int x, we'll find the LCM. Answer is equal to LCM of answer comma x. Like debug first answer, what we are getting here, is 12. Yeah, if answer is less than equal to m, we out yes, else we out no. Yes, no. Yeah, we are good to go. Okay, why? 11 pounds. Wait, hi bro, French. What's that? Branch 2474. Hey, that is what, right? J is a multiple of all the PIs. What they're asking is J is the multiple of all the PIs, right? Yes, bro, I do code forces also. I do code forces, but just say this. Thanks, bro. I like that name. That's why I picked. Because Sol, everyone use Sol, right? That's not something interesting. I thought let's make something interesting. So J is a multiple of all the PIs. And that means LCM. mm, Only God can solve the question. I was thinking something like that. That's true. That is what I also thought. At least we can hope this function should give a good output if we fucked up somewhere. Wait a minute, what's the issue now? When the Prakash want to find a meeting room that all employees can attend, specifically determine whether there exists a meeting room number J such that J is a multiple of PI for every employee I. PI for every. J is a multiple of PI. Uh, which problem you are solving now? This is one. This is the only. This is the problem. Let me give you the link. This is AtCoder. It's a practice contest. It's like we want some J where J is a multiple of that means let me rewrite the statement. J is a multiple of Pi. That means J is X of Pi's, right? That's a P1. And J should also multiple of P2, right? And J should also for all the Pi's. Let's keep it Pi's, right? So that means a number J should contain all the Pi's, right? LCM is fine. Getting 101, LCM of 243 is 12. Yeah, that's also correct. So, and J should be from 1 to M, okay. So, exists a meeting room J such that J is a multiple of Pi for every. Like, I have understand question correctly, right? Hey, bro, how you shoot? It's that correct. I pronounced correct, right? How you shoot? Yeah. Okay, let's not divert. Okay. Are you on? We are on the same track, right? I have understand the question correctly. That is what they are asking. There should be multiple of all the PIs. Hmm. Yeah, J should multiple of all the PX. See what I learned from my all the AtCoder contests. See, if you get few wrong answers, let's say there are 100 test cases, and if you get 10 wrong answer and 90 pass, that means that logically you are correct. Somewhere in something like, for example, say integer overflow. Uh, okay, if you please share the link again, let me share you the link. Let me explain the question once more. Yeah, I'm sharing the link. So let me explain the question. We want a, see, there are n employees, right? Employee I can attend a meeting if the meeting room number is a multiple of PI. So, and Takashi's target is, is there any permission denied? Okay, you have to register that contest. You can look at the screen. I am sharing the question. You have to register the contest. You can register. It's a practice contest. Just click on the register and you will get the problem statement. Let me give you the contest URL then. Uh, this is the contest URL. Check this. Now, I guess you'll have. So we want Takashi want to find a meeting room that all employee can attend. That means that meeting room, let's say the meeting room number is J. So J should be a multiple of all the PIs. So this is the property of LCM, right? Let's say X is the LCM of n number. That means X is a multiple of, okay, let me start over. So the question is asking, Takashi is working in a general affair department of a company. We need to organize a meeting for all the n employees. Okay, the company has a n employee, and Takashi you can consider as a HR. So Takashi want to organize a meeting. Okay, so he need to book a meeting room, right? Let's say that meeting room uh, has some number, say J, and there's also given that uh, ith employee will attend this meeting if J is a multiple of I, right? So let's say there are n employees. That means we have P1, P2 up. Wait, my screen. Let's say P1, P2, P3 up to Pn. So these are the requirement of all the n employees. First employee will attend meeting if J is a multiple of Pi. Second employee will attend the meeting if J is a multiple of P2. Likewise, so we need to tell, does a J exist? We have M meeting room, 1 to M. So we have to tell, does there a meeting room exist? Let's say that meeting room number is J and all the employee will attend that meeting. So this is all about question is asking. So what I thought initially is we want some J where J is in a form of like this X into P1, X into P2. All we can do is wait, let's not get see. We can do is let me find what we can do is we'll multiply all the pi, right? And we'll iterate for all the x. Let's say we'll put x is equal to 1 here, x is equal to 2. But LCM should also work, right? Why LCM is not working? And see, we are not get we are past almost this question. If I show you in submissions, my submission detail. See, we pass almost. There's only 10 wrong answer, and we have 70, almost 70 AC, 68 AC. Let me try one more time. What we can do is answer is equal to 1 for int I is equal to 0, I is less than n, I plus plus answer int x, 3 in x. Answer multiply is equal to x. If See, if answer is less than equal to m, that is also what we required. This we have, we simply print yes, else we out. But see, this won't work, right? This can go beyond the m. 4 is a 12, and this you can see. LCM is the correct approach to attempt this question, but are we missing anything? No, right? We're not missing much. The correct approach, actually, yeah. Do you have any approach? Uh, if J is a multiple of all the PIs, that means J is the LCM of all the PIs, right? See, if J is multiple of n number, that means J is LCM of all n number. Let's say what is, oh fuck, this is not correct. Why? In fact, J is a multiple of n, multiple of all n number. Actually, this is a n numbers. That doesn't mean she didn't get my question, right? It is based on divisor, yeah. That is what I'm thinking. That is what I'm thinking. Actually, this AI doesn't understand the question correctly. If J is a multiple of n different number, that means J is the LCM of all n numbers. I just want to know is statement is J being a multiple of n different number does not necessarily means J is the least common. Okay. If J is a common multiple of this number, but it is only LCM if smallest positive multiple shared by all of them. For example, numbers are 4 and 6. LCM is 12. However, 24 is also multiple of both 4 and 6, but 24 is not a LCM of. Oh, okay. But in our case, let's say LCM, see, we want a J, which is in the range of 1 to M, right? If LCM itself is out of range, then there's, let's say, our answer is equal to LCM, right? If answer itself is greater than M, then all the multiple of answer is also greater than M, right? If J is a multiple of this, then only means J mod Pi is equal to 0. Yeah, that's true. That is what, right? See, LCM means if you find LCM of all the numbers, let's say answer is equal to LCM. then this answer mod j will always give you 0. That means all pi mod j gives you 0. That is what I am claiming. Answer is equal to LCM. LCM of all the pi's. I is greater than equal to I is from 0 to n. This is what I am claiming. Is this true or not? That is what we have to. All the multiple of answers is also good. Yeah, this is fine. See, we are on the right track. Something is missing. 10 test cases. Why? Are we using long long? Yes. And then what I can say is answer is equal to LCM of answer from X. This is also correct. This is what right. Interesting. You need a number j such that j mod p1 is equal to 0. That means j must be common multiple of all the numbers. The standard way is j is LCM. This is from Jupyter. That is what I am doing, right? That is what I did here. See, wait. I'm calculating correctly, right? A of n. Let me take the input. Answer is equal to a of 0. Start with 1. And let me do this. If I'm not wrong, this is what we did, right? This is what exactly I did. It's a common sense, right? If J is a multiple of all the PIs, that means J contains factors, all the factors of each individual PI. 11 wrong answer will get here. Let's see what else is missing then. Uh, uh, this is what I'm not missing anything in the question, right? 10 to the power 18, 10 to the power 9. Mm, if there exists a meeting room, all employees can attend output, yes, otherwise, no. That is what we did. Oh, wait a minute. LCM can't be 0, right? AtCoder actually has a nice problem that makes you think. It's not based on properly mathematical. Do you need to write the entire code? Let's start. Does we need to write the entire code? You can do like, see, I have created a template. If I want to write anything, see, this is my template, right? It's if you're familiar with LitCode, you will get a function, right? So the only difference here is you need to take the input also. That's the only difference where we write only function. This is also, see, actually, there's no difference. Like, you can take input and start writing your code as similar as the only difference is here you need to take inputs. There, they have already provided inputs in the form of function parameter argument. Right? I will debug this question later. Let's move to the third question then. Question is maximizing investment. Takashi is investing in N stock. The current assets value of stock I is SI. Okay. Takashi will now perform the following operation exactly K times. Okay. Choose one of the N stock and double its current asset value. We may freely choose which stock to select for each operation, and the same stock may be chosen multiple times. If same stock is chosen multiple times, the doubling operation is applied cumulatively each time. For example, say the stock assets is this, then we'll multiply by 2. That is what they are saying. Double. Yeah. Takashi wants the maximum total assets value of n stock after performing all the key operations. When the choice of stock is made optimally, the maximum profit of assets, we can use priority queue right here. If we think greedily, uh, will you take mock interview? Yeah, we can try over weekend. In weekend, we can do this thing. Otherwise, I had an office in the morning. So what we can do is greedily we'll pick, if we think greedily, we'll pick always a stock which has a maximum assets, right? And keep multiplying by K. The catch here is K is too large. So we need to use binary exponential. Like simply you will not iterate for 10 to the power 18, right? So there's good way to calculate such thing. Let me show you. Power, binary power. This is what I'm talking about. It will calculate in log and time. So what we'll do is we'll take the input and then k, right? And we have stock and stocks, k of n. In k, we'll pick the maximum stock. Let's answer is equal to uh, maximum. Let's say max element is equal to start max element from A. What we'll do is here binary power. We'll calculate power max like 2 to the power k into, and we also need to pass mod. Mod is 1997, right? Yeah, into max and see out answer. If I understand question correctly, so this is the solution. No, right? Why? Let's dry run the first test case then. We have 1, 3, and 2. And we have two operation. What we can do is 1, we multiply. What will, so this after sorting we'll have. So we have two operations. So what we can do is multiply by 2 this stock and again multiply by 2. Multiply by 2, multiply by 2. Right? So finally we have 1, 2, and 12. Yeah, it should be 15, right? Okay, we have to print output. Let me calculate the sum. Uh, Actually, so we have only add 12. We have to add this value also. Let the sum is equal to accumulate all a comma into 0. Sum sum minus is equal to max and answer plus sum. Yeah. Okay. We have to output the mod, right? Mod. See, got it. Right. I always got wrong answer on second and AC on third. From last five contests, this is the similar pattern. We get a nice AC. We will see. This is the thing. This is the very crucial thing. If you know, then only you're able to do this question. This is the binary, like, I forgot the name. Like, we'll calculate power to just calculate what this function do actually is. Let me give you two things about this is nice way. Whenever I learn, first time I learn, I'm like, wow, there's something new in this world. See, it calculate x to the power y. What normally we do, we multiply x y time, right? So its time complexity is order of y. We'll multiply x y time. Generally, this is what we do, right? So its time complexity is big O of y. Now, what this function is not doing any magic. It's just using observation. So what it does it multiply it divide. See, what it does is it multiply by uh, instead of multiplying x, it multiply by uh, if it is even, then it divide and multiply. It is dividing, like for example, say we have to multiply y. So what it does is it multiply y by 2. What it does is it increase x into x. See, let's not make it complicated. We want to find x to the power y, right? So what we can do is we'll do like this. We want x into x to the power y by 2. This makes sense, right? This and this two are equivalent. That is what they're doing. We are increasing our base, doubling our base, and will divide our exponential by half. So this reduced time complexity to order of log y. That is what this function does. Should I debug P or move to D? Should I debug B or move to D? Uh, let's move to D because we know the concept, right? What it is solving. Let's not waste their time. We'll move to D then. Takashi and Oki play a. See, this is a game theory question now. This is also a good subset of question. Generally required a good observation here. Takashi and Oki play a game using cards. N cards are arranged in a row on a table, and the ith card from the left has the integer vi written on it. Note that vi may be negative. Okay. Two players take the card according to the following rule. Takashi goes first, Oki goes second, and then take turn alternatively. Okay. On their turn, A player choose exactly one card from either left or either right. The similar pattern of question I saw earlier. Let's see, does this question want us to solve the same recipe or not, or it is completely different? Uh, on the row, remaining take it and place it in the hand. The taken card is removed from the table and the order of remaining card does not change. Game ends when all the card has been taken. Both players know all information, including each other's strategy, and each player optimally to maximize the sum of integer written on the card they have taken. When both players play optimally, find the value obtained by subtracting the sum of integer written on the card. When both find the opti find the value of obtained by subtracting the sum of integer written on the card, okay, took from the sum of integer written. Okay, so we need to find okay, uh, okay's sum minus Takashi, right? So what we want, what is the answer, right? If both players play optimally. So question is there are n cards. Let's say this is the card C1, C2, C3, C4, C5 up to Cn. Both players take alternative. So both player has a choice, right? He or she can pick this card or this card. Likewise. So whenever we have a choice, the first tactics come in my mind is DP. But we have to think like, does DP solve the purpose here? Uh, so what we can do is at each point we have a choice. Let me formulate this into DP. If we successfully get a relationship, then there is no hard part to code, right? So what we can do is, uh, this is not the correct book. Wait, let me show you in the screen itself. At each point we have a choice. So what we can do is DP. How many things we need to keep track in our DP? Mm, I'm still thinking about second question. Why it got failed? 11 test cases. Even though conceptually it looks correct to me. Oh, what is the mistake here? Do not divert with this question. This is a doable question. You just need to come up with the optimal DP state here. Or it is not even a DP question. There's a similar question in code forces. Unique I saw the live stream of Unique. It's a Duke 3 question. It's a C question. That is also I'm recognizing. Let me search. There's a code forces question. Go to contest. Let me see. Div 3 filter. It's a long back, not this, right? See, it's a playing a game. No, this is not. Does this help that question? Say replace and sum. Is this question? Uh, no, no, this is not that question, right? Allow perform following operation. Replace. Yeah, no, this is not that question. Use file. No, this is also not that question. No, this is. So I will not. I'm not remembering. Like it's a due three or due two. Exact similar. This. What we can do here is. Let's think. So player one. If player I is done, what player I do? Uh, what player I do is it has a choice, right? We can't run bit mass here. Otherwise, this question is brute force, bit mass brute force. We'll do brute force over bit mass. But what player I do is it. Okay, so we can create DP like this. Easiest way is we need to track player. Let's say player, then index. No, no index, right? Because index doesn't make sense here. And what is the final like answer? If we have a DP table, what is the final answer? That is also not very clear, right? Here, clear means I'm not clear. Like, what is the final answer? What we can do is, oh, final answer is n is always odd or even. Doesn't matter, right? It doesn't matter. N is odd or even. Yeah, it doesn't matter. N is odd or even. So we want after processing all the n elements. Yeah. So final answer is dp of 1 comma n. That is the score of player OK after processing all the n elements minus dp of 0 comma n. Right. So dp of I represents OK. I got it. So we can define dp like this. dp of pi comma like player, it can be 0 or 1. I represent, this is I, represent the optimal score of game if Oki and Takashi take alternative turns till 0 to I index. Yes, this is correct. So time complexity can go, then it is fine, right? This is fine. Final state we have decided. Transition we have to think of now. We have defined the DP. We have defined what is the answer. Now we have to think of what is the transition, like how we'll fill the DP table now. So for that, let's say, ah, ha, ha. Oh, fuck, we have only 11 minutes left. Let's not for let's not come up with a solution because it will take time, right? Because I'm not sure. I have to think of all the possible test scenarios, and then might this formation went wrong also, right? Let's debug the code. We are getting wrong answer. We're able to debug successfully in 10 minutes. Are we? Are we guys able to debug this code? So, question is asking, does there a J exist where J is a multiple of all the PIs? J is a multiple of all the PIs. Just a minute. We can do is P1, P2 up to Pn. That means J is the LCM of this, right? Into X. Let's say. It's a X. LCM of all this number into X. Right. This is what J. Takashi want to find a meeting room that all the employee can attend, specifically determine whether there exists a meeting room number J, such that J is a multiple of Pi's for each employee I. What the fuck? Missing here. La, 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 lorry. This is what we are to find, right? And X we can iterate also. X equal to 1. Sure. But there is no sense, right? If we take X equal to 1 and this number itself is greater than M, then there is no sense of taking X equal to 2 right here. So what we did is we'll calculate the LCM. If LCM is less than equal to M, we print yes, otherwise we print no. This solution looks fucking perfect to me. I don't know why we are getting 11 wrong answer. Uh, this question kills me with anxiety. Do you guys have any idea what I'm missing here? La 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 lorry. Do some typing and we'll think. Get your Wait, had Java even develop on. That is what, right? We will calculate the LCM. That is what our J, right? But why we are getting wrong answer here? Oh, ho, ho. This is something interesting. I want to know the solution. That's why I'm waiting for 5 more minutes. What is the solution? The first is the multiple of all pi. Yeah, this is correct. Wait, small has nation, so take show a response. Ah, we'll do typing race. Guys, do you want to join typing race? Typing this multiplayer. No, this is not looking good. Any good typing this website? Ah, this is typing racer. Let's go. Fuck, fuck. Don't you worry, Ladybug. Fuck, I'm not good. We come home like a mile. No, sorry, I'm not. I have practice of smaller case only. Fuck, seems like I'm the last one to finish this race, right? You thought I finished? Fuck, I finished first. How bad other people are. Race again. Let's do race again. All the blue light reflections that color my mind up when I sleep, and the lower six rejections that a company company I keep, all the desert perception that got just a little too deep. Hey, I can bleed as well as anyone, but I need someone to help me flip. Yes, I finished first again. We can. We have 2 minutes now. We can do here is I was taking input correctly, right? And keyboard A. Yes, input is correct. Input is correct, right? Mhm. LCM, the least common factor, least common multiple, right? That means a number element is always divisible by individual. That is the fucking things they are asking, right? So I said say multiple. All employees in attend this typically different whether it at least a meeting in J. But the J is a multiple. That is J mod. Yeah. Yeah. Now we can check solution. GCD was what? GCD what is happening here? And GCD. Wait. Yeah, this guy did same, right? Oh, it's fine with GCD. No. This is what I did, right? It find GCD, LCM, and this is what I did. This is what I did also. What's wrong? I did. This is the question. I also did this thing, right? So why we are getting wrong answer then? You have calculated written m plus 1. You have modified this LCM, right? Oh, AI can be 0, right? What? No, it can't be. AI can't be 0. What's it possible? Oh, there is overflow. I told you, right? There is an overflow. Yes. If answer is greater than m, we out. No, this is the what this is. Otherwise, is always yes. This is what we have to check. Yes. No. I hope this is the only thing, right? If something else, then I might miss If this is, then this is I can consider as a silly mistake. If this works, then if this doesn't work, then something else I'm missing in the solution. Still three wrong answer. Why? Why still three wrong answer? 10 to the power 9. What we can do is we just need to prevent overflow. Is there any better solution? Wait, oh, what Egon has said is I'm not able to understand. What the fuck is this idea? How solve? Wait a minute. Wait, okay. What is study is it prevented the overflow. We can do. I have to mug a few things. Otherwise, every time I try to prove and code, that will fuck it up the time. Right? We want if I should less than 180. Equal to. So let's say x into y this, then x should less than equal to 1 is 18 by y. If if answer if I is less than equal to 1 is 18 by answer if this is greater than and also will print no and will return here. This will prevent overflow, right? Let's make it int here. This should prevent overflow now. Yes, yes, yes. I had a 11 fucking wrong answers. Then I do something like I tried to prevent. With this condition, we have come up from 11 to 3, right? Let's see how far we can go from here. Do we get AC? If not, then I will try once with my free mind. We are still getting three wrong answers. That's fine. So that's it's all about today. We pretty fast solved third question right today. That's also thank you for joining everyone. Take care. Bye bye.